All right, ladies and gentlemen, today we are going to work on factoring. Factoring is one of those skills that no matter how many times we do it, always seems to be fleeting for you guys. We always tend to forget it. So we're going to be creating a lot of things going on today. So make sure you guys are paying attention. I'm sorry I couldn't be here today, but we'll get through this, and I'll even spend some extra time on Monday going over it with you. So first things first, make sure you guys have some paper out. I'll give you a few seconds to go ahead and get that started. You done yet? Still taking way too long. Okay, I'm done waiting. All right, we are going to be learning factoring through a method that I always go through called the factoring tree. So here is our factoring tree. Now, as we go through this, I'm going to be giving you guys a bunch of examples, so make sure you guys try to stay as organized as possible. Okay, I want this one to stay on the main page. This is like the most important thing that we can remember. Anytime you factor, you are going to start with a GCF. What does that stand for? It stands for greatest common factor. Now, we've actually done this a lot already, but let's do a couple examples just to make sure that we understand it. Okay, so over here we've got the GCF problems. And we'll come up with one. We'll just say it's 4x to the 5th power minus 8x squared plus 12x to the 6th. Okay. Oh, that's not problems. That's much better. Okay, so a GCF means when you look at every term, and I've got 3 terms here, I want to see what's the biggest thing, the greatest factor that I can pull out of each term. So I start with my numbers, 4, 8, and 12. What's the biggest number that goes into them? You got it, 4. So we're going to divide them all by 4. But I also have to look at the variables. I've got x to the 5th, so I've got 5 x's here. I've got 2 x's here, x squared, and I have 6 x's here. You want to pull out the most you can pull from every term. So I can only pull 2 out. That's the most I can take out. Why can't I take 3? Because there's only 2 in the middle term right here. So I'm going to take 2 from this term, 2 from this term, and 2 from this term. Okay? The GCF is the 4x squared. We are going to pull that GCF out, so 4x squared comes out, and then you just have to tell me what's left when you do the division. 4 divided by 4 is 1. X to the 5th, you had 5 x's, but you took 2 out. X to the 3rd. Negative 8 divided by 4 is negative 2. You had 2 x's, but you took 2 out, so they're gone. They've canceled. 12 divided by 4 is 3. You had 6 x's, but you took 2 out. X to the 4th. And what would be a good practice for you guys is make sure you write them. They call it standard form, but it's the biggest exponent first. So 3x to the 4th should come second, or first. X to the 3rd is the second biggest exponent, so that should come second. And the minus 2 should come at the end. Okay? All right, one more we'll do before we move on. So let's make it 6x to the 3rd, y to the 5th, minus 8x y to the 7th, plus 10 y squared. Okay, now in this case, when I look at all my numbers, my coefficients, 6, negative 8, and 10, the biggest number I can take out of those, you got it, 2. So we're going to divide them all by 2. Okay? Now when I look at my x's, in the first term I have 3 x's, in my second term I have 1 x, and I don't have any x's in my third term. So I cannot take any x's out. So x's are going to stay, we're going to leave them alone. I'm going to take out the y's now. I have 5 y's, 7y's, and 2y's. The most I can take from each term, 2. So I'm going to take 2y's out of each term. So 2y squared is my GCF. That comes to the outside. And then let's find out what's left over. 6 divided by 2 is 3. I didn't take any x's out, so x to the third stays there. And y to the fifth, but I took 2 y's out, so y to the third. Second term, negative 8 divided by 2 is negative 4. I didn't take any x's out, so those stay alone. And I had 7 y's, but I took 2 out, so that's y to the fifth. And last but not least, 10 divided by 2 is 5. I had 2 y's, but I took 2 out, so that's it. They're all gone. Okay, so these are the GCF problems. You always, always, always try to do a GCF first. Now, after you guys do the GCF, let's go back to our factoring tree. I think it's there. I want you to take a look at how many terms you have. We've got a few options here. So we're going to spread out our tree a little bit. If you have 2 terms, there's going to be a way to factor those. Or you could have 3 terms, or you could have 4 terms. Okay? We are going to start with what you guys actually know you've been working with the most, those 3 terms. So, 3 terms, I call them the short method and the long method. Okay, now, the short method is when your a value, your leading coefficient is 1, and your long is when your a value or your leading coefficient is anything but 1. So let's go to another sheet. We'll show you a few short-term methods and long terms. So there's our GCF problems. Let's scroll down a little bit. Okay. Here's our short method. Here's our long method. All right. So let me give you the easier ones to work one first. X squared minus x minus 12. And a long method problem would be a 2x squared. Hold on, let me just write this out. Let's do minus 5. And we'll put a plus 3x in the middle. Okay. Look at your leading coefficient, the number next to x squared. Over here, there is no number next to x squared. So that means my a value is 1. In the long method, if I look next to x squared, I've got a 2 there. Because I have a 2 there, that means my a value is not 1. So that's how you guys can tell whether you can do a short or long method. Okay, now the short method is really quick. I want to find the factors of negative 12 that add up to negative 1. Well, if you write them out, 1 times 12, 2 and 6, 3 and 4. The only way that I could get negative 1 is to do 3 minus 4. Hopefully you guys are moving on to your next class. That was the bell. Well, not your bell. You guys stay seated. Okay, so I know that 3 times negative 4 is negative 12. And I know that 3 plus negative 4 is negative 1. So the short, you guys are done. X plus 3 and x minus 4. Now in the long method, I'm going to move this down a little bit. I want to have some more space. That looks much better. In the long method, because you have this 2 here, there's a system to it. Okay, it just takes some getting used to. You have to do it a number of times, but you're going to do 2 multiplied by negative 5 is negative 10. You want to find the factors of negative 10 that add up to 3. Okay, just to save time, 5 and negative 2. When I multiply these, I get negative 10. When I add these, I get a positive 3. So that works out. Okay, so the long method is also called splitting the middle term. And what that means is I have 3 terms here. 1, 2, 3. I'm going to split the 1 in the middle. So I have a 2x squared. this 3x is going to get split up between a positive 5x, that was the number I used from up here, and a negative 2x. Then you have a minus 5. Okay, so now I have 1, 2, 3, 4 terms. Anytime you have 4 terms, what we do is it's called grouping. So you guys are going to group them. And just before we keep going, here's the important part. That negative right here, this negative 2, that has to go inside the parentheses. You need to have a plus sign on the outside. So make sure when there's a minus sign, you group that minus sign or that negative sign inside the parentheses. Okay, so at this point, we are going to factor out using a GCF as much as we can. So what can I take out of 2x squared and a 5x? You guys got it? I can only take out an x. So if I take out an x, I'm left with 2x plus 5. Now, I want this second parentheses to be able to match this one right here. So what do I have to divide negative 2x minus 5 by to get 2x plus 5? You guys got it. Negative 1. If you take out a negative 1, this will leave you with a 2x plus 5. Now, at this point, you got to notice these parentheses are exactly the same. That's how you know you did it right. If they're not the same, something went wrong. So that's going to be one of your answers, 2x plus 5. The other part, let's take a look at what is outside. You have an x and you have a negative 1. That becomes your second parentheses, x minus 1. And there's your long method. Very good. Now, before we move on, I want to point out that there's some times where you might look at a problem and you might think it's a long method, but it's not really. So let's do one more together. Let's do it right here. Separate that out. And then this is problem number 3. Let's do 2x squared plus 2x minus, what'll work? 24. Now, when you look at this problem right here, you might be thinking that it's a long method. There's a 2 next to x squared. But if you also look, you can see that all of these have a GCF of 2. You can take out a 2 from each one. So if you take out that 2, now inside you're left with x squared plus x minus 12. Well, now there's nothing next to x squared, so that makes my a value 1. So you can still do the short method here. So factors of negative 12 that add up to 1 are 4 and negative 3. So you can write this as x plus 4, x minus 3, and do not forget that GCF that you took out in the beginning. That 2 has to drop down. Okay, so that covers short and long method. All right, so let's go. So we did short, we did long. That's if you have 3 terms. Let's keep going from here. Let's go over to 4 terms because we actually just talked about this one. If you have 4 terms, we are going to use a method called grouping. Okay? And actually, you did this when you were doing the long method. So these kind of go hand in hand when you guys are working together. So let's show you a couple grouping problems. 2x to the third power minus 4x squared plus 7x minus 14. So this is a grouping problem. Hopefully your organization is a little bit better than mine. So if you looked right up here, let me draw this line for you so you can see it. You don't have to do this, just look. You had 1, 2, 3, 4 terms. Because you have 4 terms, I need to group them together, just like you did before. 1, 2, group the first 2. 3, 4, group the second 2. Okay, where were we? I had to take a little bit of a break there to tutor some students. You guys know who you are. Okay, so in the grouping, Same thing now. We're going to group the first two, we're going to group the second two, and we want to take out a GCF. So the first two, what can I take out of these two? Well, they're both divisible by 2, and they both have at least 2 x's in each one. So I'm going to take out 2x squared. If I take out a 2x squared, I'm left with x minus 2. In the second parentheses, what can I divide both of these by? Well, I can divide them both by 7. So if I take out a positive 7, I am left with x minus 2. Again, you have to make sure that these parentheses match up. Are they exactly the same? Yes, they are. That's a good sign. So that's one answer, x minus 2. And then what's left over is your second answer. So I have 2x squared, and I have a plus 7. These are my 2 factors for this one. All right, that's grouping. Now the rest of the day is going to be spent on these 2 terms over here. Okay, now one of them should seem very familiar. That's called the difference of 2 squares. Difference of 2, and then there's my square. Okay, and then today what we're also going to learn is we're also going to learn 2 new ones. So we're going to learn the sum of 2 cubes and the difference of 2 cubes. If you wanted to, you can draw a nice little cube in there. There. Okay? So this is where we're going to spend a majority of the rest of the time here. So let's take out another sheet of paper. Go to the difference of 2 squares. Now the word difference means subtract. 2 talks about the fact that you have 2 terms. And squares means they are perfect squares. Which means we have to remember all of our perfect squares, at least a good number of them. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and keep going. See if you can erase me. 81, 100, 121, 144, 169, 196, 225. Good. So now we know all of our perfect squares by heart. These are all the things I can take a square root of without getting a decimal. Okay, so basic difference of 2 square problems. I've got x squared minus 81. If I... No, there's a phone. Give me 2 more seconds. Okay, so x squared minus 81. If you notice, if I take the square root of x squared, I get x. If I take the square root of 81, I get 9. Okay? But that's only one of my parentheses, x plus 9. I've got 2 x's here. So one goes to the first set of parentheses, the other goes to the second. And from 81, using 9, I don't want to get 81, I want to get negative 81. So if I have a positive 9 here, I need a negative 9 here. What do we call these? We're thinking. These are conjugates. So do not forget that, okay? So again, when you do the difference of 2 squares, you need 2 parentheses. So a little bit more challenging, I could show you something like 121 y squared minus 1. Okay? So if I take the square root of 121 y squared, square root of 121 is 11, square root of y squared is y. If I take the square root of 1, I get 1. So I have 11y plus 1, and I also need the conjugate, which is 11y minus 1. Now before, we talked about certain things having quadratic functions or quadratic tendencies. Well, the same thing works for factoring. So as an example, if I have x to the 6th minus 100, if you notice, I can take the square root of x to the 6th. Okay, now, some people might know this, some people might not. It's x to the 3rd. I can take the square root of 100. Oh, it's not 100, it's 10. So the easiest way that I could explain it is if you have 6 x's, you want to split them up equally. So 3 go to your first parentheses, and 3 go to your second parentheses. The square root of 100 is 10, so 10 and 10 gives you 100. One's plus, and one is minus. All right. I hope you guys are feeling pretty comfortable with this, because we're going to show you that we can make these things look very, very challenging, even if they are not. So if I wanted to, I could write something like 20 x to the 5th, y to the 3rd, and minus 125 x to the 5th, y. So when you look at this problem right here, we think, how are we supposed to know that it is a difference of 2 squares? Well, just remember, you always want to start with a GCF. 20 and 125. What can we take from both of these? The biggest number we can take is a 5. Okay, now look at my x's. I have 5 x's in the first one. I have 5 x's in the second. That must mean I can take 5 x's from each term. And when I look at y to the 3rd and y, I've got 3 y's in the first term. I've got 1 y in the second term. That must mean I can still take 1 y out. So I have a GCF of 5x to the 5th y. And then what's left over? 20 divided by 5 is 4. These x's cancel. And y to the 3rd, but I took out a y, is y squared. Negative 125 divided by 5 is negative 25. The x's cancel and the y's cancel. So once you do a GCF, now you can look inside these parentheses. And if you notice, oh, I just used green bay colors. I'm sorry, I'll never do that again. Let's back that up. And if you notice, it's looking a little better. I can take the square root of both of those. So the square root of 4y squared is 2y. The square root of 25 is 5. So to make the conjugates, I get 2y plus 5, I get 2y minus 5, and do not forget about that GCF. That's the difference of 2 squares. Okay, which means we've done this. We've got the sum and difference of 2 cubes left. Now, let's go over one at a time. And actually, for these, there are some formulas that you have to remember. So make sure you guys take these down. Okay, let's get a new sheet. Okay, so the sum of 2 cubes. Sum meaning adding. 2 means there are 2 terms. And cubes means that they are cubic, or perfect cubes. That means that we have to remember all of our perfect cubes. So 1 cubed is 1. 2 cubed, 2 times 2 times 2, is 8. 3 cubed, 3 times 3 is 9, times 3 again is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 cubed, you got it, is 1,000. We'll stop there. Okay? So you need to be able to recognize now the perfect cubes as well, not only the perfect squares. And after you get this, now we actually have to know the formula. So if you have something being cubed, a to the 3rd, The sum means plus, so plus b to the third power. When they give you this, we can factor it into the following. A plus b, a squared minus ab plus b squared. So if they give you the first one, up at the stars, we can factor it in this method. Okay? This is a very important formula, so please do not forget it. So we'll start nice and easy. If I said you have x cubed plus 8, well, you have to recognize that if you take the cubed root of 8, or if you take the cubed root of x, and this is how we show this, the cubed root of x, this 3 and this 3 will cancel. So that's just x. If you take the cubed root of 8, you get 2. Okay, now on a calculator, you can't just type in, I don't think the fancy calculators, you have them as much. So to do this on a calculator, you take 8 and you raise it to the 1/3 power. Now if you do that, I'll give you a few seconds to mess around with that, you should get 2. Okay, and that'll work for any of these up at the top. So if you take, like, let's say 216, you do 216 and you raise it to the 1/3 power, and make sure you put those fractions in parentheses, you will get 6. Don't believe me? Go ahead and try it. Okay, that means that the x is your a value, and the 2 is your b value. Once you know your a and your b values, you can just substitute them into the formula. So this x will go any spot where you see a. This b, or that 2, will go anywhere where you see a b. Okay, now I know that looks pretty confusing with a lot of arrows, so let's start this over so we can do it again, okay? Now, we have x to the third plus 8. Another way of thinking of this is we have x to the third plus 8 is 2 to the third. So this is my a, this is my b. So if you know the formula, and again you have to memorize this, a plus b, a squared minus ab plus b squared. Instead of a, you're going to replace a with x. So a plus b becomes x plus 2. A squared, well, if a is x, this becomes x squared. There's a minus sign, so make sure you put the minus sign. A and b, so you take these two things and you multiply them. 2 times x is 2x plus, and then b squared, take your b value, which is 2, and square it, and you get 4. Okay, there's the bell. I got to start teaching. I'll come back in probably about an hour, but you guys won't know that, so hold on one second. Okay, so let's try another sum of 2 cubes. We'll do, let me scroll up here, figure out what I want to actually use. Okay, 343 and 216. We will do 343 y to the third plus 216 x to the third. So in this case, we notice that 343 and 216 are both perfect cubes. Now if we scroll to the top, we can see that 216 is 6 cubed and 343 is 7 cubed. So when I come down to do this problem, I can write 343 as 7y cubed, and I can write 216 x to the third as 6x, all being cubed. Okay, so what this means is when you can write them all as one thing to the third power, we can cross out these exponents, and we know now that 7y is our a and 6x is our b. So from here, we just have to apply the formula. So scrolling up here, a plus b means 7y plus 6x. And then a squared, meaning take 7y and square it, we get 49y squared. There's a minus sign in this formula, so we use minus. A times b, meaning 7y times 6x, is 42xy. Plus, so let's put a plus sign in there. And b squared means take 6x and square it, we get 36x squared. Okay, so we just apply that over and over and over again. Okay, so we've got one more type of factoring to go through, and that is the difference of two cubes. The only difference, get it, between sum and difference, well, sum means addition and difference means subtraction. So, for the difference of two cubes, we need another formula. So, if I have a to the third minus, that means difference, b to the third, I can factor it using this formula. A minus b, a squared, plus ab, plus b squared. It is very similar to the sum. In fact, the only thing that changes is this minus sign and this plus sign are the only two things that change. They switch back and forth between the sum and difference. Okay, so I'm going to get rid of that. And we're just going to do maybe one or two more problems, and then we'll go from there. Okay, so why don't we do y to the third minus 27. Okay, so y to the third, that's fine. But I can rewrite 27 as 3 to the third power. Again, I want to make sure I see these exponents as 3's. Once I do that, I can cross them out. And then that makes y my a value. Oh, that was a bad circle. Let's try that again. And that makes b my, or 3 my b value. Once you know these, you just start plugging them into the formula. So a minus b becomes y minus 3. A squared becomes y squared. Now this time it's plus, so we're going to write plus from that formula. A times b means multiply these. That gives me 3y. Plus b squared, well, my b is 3, so that becomes 9. Alright, how about one more, and then I'll let you guys start your homework. Okay, so I'm going to scroll up here and take a look and see what numbers I want to throw at you. Okay, I think I got it. Last problem of the day. 16 x to the fourth minus 128 x. Okay, so when you take a look at this one, you always have to go back until what's the first step. Okay, because as of right now, 16 is not a perfect cube, neither is 128, and this x to the fourth, it doesn't even say x to the third. So there's some issues that we have to work out first. But if you notice, we can always start with a greatest common factor. So when I look at these, well, the first thing I see, well, let's see if I can take out a 2. Okay? And then x to the fourth and x, well, I can take out an x from both of these. If I do that, 16 divided by 2 is 8. I had 4 x's, but I take an x out. That's x to the third. Minus 128 divided by 2 is 64. I had an x, but I took an x out, so I don't have any left. Well, if you look at this one right now, you can notice that now they are both perfect cubes. But 8 and 64, they've got another GCF. You can take out a bigger number here. 8 and 64 are both divisible by 8. So you can still take out another 8 here if you didn't see it before. So if you take out an 8, that 8 comes to the outside and it gets multiplied by 2x. So that becomes 16x. And inside you will have x to the third minus 8. This GCF, this 16x, that's just going to hang on the outside the whole time. So we're going to ignore that for right now. What we are going to focus on is the x to the third minus 8. 8 is a perfect cube. So it can be written as 2 cubed. Okay? So this x, that's my a value, and the 2 is my b value. So this is what I plug into the formula. So according to the formula, it's a minus b, so x minus 2. And then you have a squared, so x squared, plus ab, so x times 2 is 2x, plus b squared, 2 squared is 4. And do not forget about that 16x, that GCF that we took out in the beginning. And that has now been factored. Okay, so I know this is going to take a while. Give it a try. Follow this table. So when we come back to this, follow this order. Start with the GCF, and then from there, see if it's 2 terms, though, maybe it's one of these. The difference of 2 squares, the sum of 2 cubes, or the difference of 2 cubes. If it's 3 terms, it's either going to be the short or the long method. And if it's 4 terms, you're going to use grouping. Okay, we'll talk about it more on Monday. You guys have a good weekend. You guys can get started on your homework now, and good luck. All right, we'll see you guys later.